So welcome to Master Academy of Mathematics. This is a video session on multiple integrals. So to have an information of multiple integrals, you know about integration. Integration can be done with respect to the variables. So depending on the number of variables, that integration divided into several categories like single integral, double integral, triple integral and so on. So at present we are going to use the multiple integrals, means it is an integration involving more than one variable. So at present I am going to consider only two different categories. One is, we call it as double integral, and the second one is nothing but triple integral. So only we are going to take two different types of integrals, double integral and triple integral. Both are in the multiple integrations. Now in order to evaluate this double integral, so it is an integral involving the two variables. So I am supposing a function f of x comma y. It is a function involving the two variables x and y. Simply I am denoting with f of x comma y. Corresponding to this function, the double integration can be calculated based on four different categories. I just give you the four categories first. One is, no limits are given on the integration. No limits are given on the integration. Second one is nothing but, no limits are given on the integration, but they are given one equation. One equation. No limits with one equation. Third category is nothing but, no limits are given with two equations. Coming to the fourth category, limits are given. So these are the four different categories in order to find out the double integration corresponding to the given function f of x comma y. Now I explain one by one in a systematic manner. Now let us start case number 1. In case number 1, I am supposing that limits are given. Limits are given. So when the limits are given, now we need to calculate the double integration corresponding to the given function. In order to identify that, again it is divided into certain categories. The first one is, suppose the limits are real numbers. If the limits are real numbers and f of x comma y, that is equal to f of y comma x. What is the meaning of f of x comma y equal to f of y comma x? If you interchange x and y variables, if you get same function, then order of integration has no importance. So what is the meaning of order of integration has no importance? That means either first one is x integral or second one is x integral. In any of the cases you are going to get the same answer. So the first case I am giving, when the limits are given and the limits are real numbers satisfying f of x comma y equal to f of y comma x, either first integral is x integral or second integral is x integral, you can find out your answer. I am going to take one more. If the limits are real and f of x comma y not equal to f of y comma x, if that condition is satisfied, then double integral f of x comma y dx dy. The meaning of this is, this dx dy, you just reverse it. So the first one, it is nothing but y integral, second one is x integral. This is f of x comma y dx dy. This is the meaning. Similarly, double integral f of x comma y dy dx. The meaning of this is, it is reversible. The first one is x integral, second one y integral, f of x comma y dy dx. So when the limits are real numbers, depending on the condition, you are going to calculate the integration part. Now I am going to take one more case when the limits are given. In the third case is if the limits are in terms of variable. That means the limits are represented in terms of variables. In that case, then the limits are opposite to the variables. The meaning of this statement is, suppose if the limits are represented in terms of variables, then that limits are corresponding to opposite variables. If the limits are represented in terms of x variable, those are the limits corresponding to y variable. If the limits are represented in terms of x variable, the corresponding limits are limits to the corresponding y variable. So opposite. If they are represented in x, limits corresponding to y variable, represented in y, limits corresponding to the x variable. So this is the important case when the limits are given in the double integration. Now let us take case number 2. In case 2, limits are not given. If limits are not given and one equation is given, limits are not given but they have given one equation. In that particular case, in order to evaluate double integral, first you select the second variable from the given equation. That means the given equation consisting of two variables x and y. From that equation, you are selecting first y variable. The corresponding limits are 0 to that y variable is represented in terms of x variable. Then x variable limits are taken as 0 to, you are taking a particular value for y equal to 0. That means in order to get the x variable limits, start with 0, you will get one value when you substitute y equal to 0 in the given equation. So by using these two limits directly you can find out the integration. Now coming to case number 3. The third case is limits are not given, and two equations. They have not given the limits but they have given the two equations. So corresponding to those two equations, you solve those two equations. So that you can find out the values of x variable. Only you calculate the values of x variables and y variable limits are taken depending on the given equations. This is from first equation, you are calculating y value, and from the second equation, you calculate y value. So here, directly you will get x limits and y limits from the given equations and find out the double integration. That is coming under case number 3. Now I am taking the last case number 4. Case 4 is nothing but limits are not given and no equations. So no equation is given, no limits are given. Then you are directly finding the double integration. You are using only the general integration process. General integration means just you are supposing f of x comma y dx dy. This is equal to, first you apply either x integration or y integration, then again you are entering into the next integration path. So apply your general integration procedure in order to calculate that double integration. So till now I have given the 4 different cases. First case is limits are given, and again that is divided into certain categories. Coming to the case 2, limits are not given, only one equation is given. Case number 3, limits are not given but two equations are given. Case 4, limits are not given and no equations are given. Then you are applying general integration process. So this is how you are calculating the double integration corresponding to the function.